welcome to the Plutus IAS. Today we are going to discuss an important burning issues of geography, which is recently in news about the El Nino and how El Nino is getting impacted through other developments of the climate, and even climate is getting impacted by the El Nino, right? So monsoon is also there in coming. So how El Nino will be impacting over the monsoon, and how the socio-economic condition of India would be getting impacted through El Nino and poor monsoon would be discussed here. In technical terms, we'll discuss first of all about what is El Nino and how it is impacting, and Indian Ocean dipole, positive, negative developments, how it would impact the intensity of El Nino etc. So first of all, we'll see about what the El Nino is. Basically, El Nino is a ocean current, right, originating nearby the coast of Peru in East Pacific Ocean. This is the warm current developed in Pacific Ocean, South Pacific Ocean. Generally, you will see, if you see this is your ocean bottom, which is occupied with water from bottom to top. Warm water is occupying above, cold water are underlying in nature. When some kind of force is exerted over the upper part of the ocean water and it drags the water from one side, then cold water will upwell to the surface. Cold water will upwell to the surface. And if such kind of force is there in the form of wind, if any wind is there which drags the water from one side to other, then cold water lying bottom to the ocean will be upwelling, right? This upwelled cold water would come to the surface in the form of cold current. So in tropical region, this is the cause how cold currents are originating in those regions, right? If you see it on map, see this is the diagrammatic representation of world. If you see the cold current of here East Pacific in the form of El Nino, or here in the form of Bengula, or cold current of Western Australia, Western Australian current, all are cold, but originating due to the same phenomenon. Suppose this is the ocean bottom, this is the ocean, top to bottom structure. So top level is getting with El Nino. If some kind of force is there exerted over the surface water, then lower water, cold water will come to the surface, upwell to the surface, and will occupy the surface as cold current. Normally in place of El Nino, like warm current, there is presence of Humboldt current, right? Humboldt current. Here, since some kind of wind is there which drags surface water from one side to other, यहाँ से नीचे से विंड चलता है जिससे नीचे का ठंडा पानी ऊपर आता है, and see some kind of Humboldt current like or Peru current, like cold currents are there developed at the coast of Peru, right, in normal seasons. And this dragging force is trade wind. Here trade winds are moving. If you see another, map, you will see here there is presence of trade wind, right? This is the presence of trade wind found above to the ocean surface. This is the globe, equator, subtropical region. Upper subtropical has got trade wind of upper tropic, and trade wind of lower tropic is there. This wind causes drag, some kind of force over the ocean water, causing cold water to get upwelled as what you say Humboldt current. This is the Humboldt current, as I have already explained. This is cold water getting upwelled with the impact of trade wind in this way, right? So this is the cold current generated as Humboldt current. But what if such kind of trade wind to drag these cold water from the bottom is getting weakened or stopped? Then this upwelling will again be stopped. If upwelling would not be there, then surface would be occupied with warm current, right? Surface would be occupied with warm current. Hence, see, there would be some kind of a specific current known as El Nino current. What happens in Pacific Ocean? This is the El Nino phenomenon which happens at the East Pacific Ocean near about the coast of Peru, where upwelling is getting stopped. But this is not the simple phenomenon. It is related to two phase of the sun. That is waxing phase and waning phase of the sun. When sun remains in waning phase, that is to say low energy phase, right? When sun remains in low energy phase, as the name is saying, there would be less energy coming out from the sun, which causes less amount of heat to be reaching to the equator region. Hence, less amount of evaporation would be there from equatorial region and resulting less upliftment of air from equatorial region, and subsequently there would be less subsidence in subtropical region. So see, if this is the world map, then again this is equator, and if there is less uplifting of air from equatorial region, then subsidence from both side of the tropic, that is see both side of the tropic would be getting with less subsidence. This is the Tropic of Cancer and this is the Tropic of Capricorn, like this. Less uplifting, less subsidence. Less uplifting, less subsidence. Hence, the pressure of subtropic would be comparatively less. So, high pressure would be reduced. Since there is upliftment in equatorial region, so there would be obviously low pressure. But in subtropic, where there was earlier high pressure, because of the subsidence of air, would get weakened because of the less energy phase of the sun, which leads to less piling of air in subtropical region, right? Less piling of air in subtropical region. Hence, from this high pressure to low pressure, earlier what the movement of trade wind was there would be weakened, So the strength of trade wind would get weakened, which was earlier causing upwelling of water from the bottom, right? Because this is trade wind. If upwelling is getting weakened because of the less strength of the trade wind, then what happens? Less upwelling, and because of less upwelling, see here there would be warm water present over the surface, and this warm water is taken as what you say El Nino, right? But see, this is the phenomenon of low energy phase of the sun. Then what happens to high energy phase of the sun? When there is more amount of heat to be present on equatorial region, there would be more uplifting of air and subsequently more subsidence in subtropical region. More piling of air would be there, which results into strengthening of the trade wind. If there is more strength of trade wind, then more upwelling would be there. More and more cold water would be there present over the surface. Hence, in those years, there would be formation of a specific current that is known as La Nina current. So, in neutral years, you can say in comparison to El Nino and La Nina years, there is presence of Humboldt current at the coast of Peru, normally. But during the El Nino years, there is El Nino warm current. But the year when El Nino disappears, there is strengthened upwelling of cold water from the bottom in the form of La Nina current, right? So we have El Nino current, we have El Nino and La Nina current. See, El Nino is impacting the monsoon negatively, while La Nina impacting the monsoon positively, that is strengthen monsoon would be there coming, while in case of El Nino, weak monsoon is there. As it is said, 98% monsoon would be there in the current year. With the impact of El Nino, this year monsoon would be reduced to 98%. Normal, more than 100% monsoon is required to be coming, as last year it was 108%. But this year it is taken as to be reduced to 98% or even below. This will be expected due to the impact of El Nino. But some years are there when even El Nino comes to the India or Indian Ocean, but monsoon is not weakening. This is because of the impact of Indian Ocean dipole, right? So sometimes Indian Ocean dipole impact is there, which is negating the impact of or reducing the impact of El Nino current. So in next video, we'll be discussing about how IOD, Indian Ocean dipole, is decreasing or de-intensifying the impact of El Nino. Thank you.